Hi everyone, this video is an introduction to MATLAB, and as you might know, MATLAB stands for Matrix Laboratory and is a very powerful tool in creating codes, calculation, and programming. Put the cursor in front of this command prompt and type 5 plus 3, then the enter key. You see that the result of this addition would be returned here. Now 5 minus 3, enter. Now 5 and the asterisk, 5 times 3, then enter. Again, it will return the result of this multiplication. Now you can type 5 over 3, enter. Here is right division. We also have left division, so I would type 5 backslash instead of forward slash and 3, then enter. Here you can see the result is different from the previous one because here 3 is divided by 5. So if I type 3 forward slash 5, enter, here you can see that the same result is returned here. So backslash and forward slash do reverse operations for you. We have exponentiation. So for example, 5 to the power of 3, enter. We have exponential. So as I type e to the power of 1, enter, you can see an error will pop up here because e is not defined in MATLAB. You need to type exp, exponential, x of 1, then enter. Now you have the base of natural log here. And here, if you want to clear the command window, you can type CLC, clear command window. So just type CLC, enter, and the window will be cleared for you. You can also assign a value to a variable in MATLAB. Say for example, if I type A here, then the equal sign, then I assign 11 to this variable and then enter. It will return the value of 11 for me. Now, if you don't want MATLAB to return the value for you, just after you assign, so this time if I type 13, then the semicolon, enter, it doesn't return the value of A for me, or any other command. So say for example 5 plus 3, enter, will return the result for me, but if I type 5 plus 3, the semicolon, enter, the result, the execution of this operation would no longer appear here. Now again I can type CLC, enter, and it will clear the command window for me. In order to type text or comments on this command window, you need to type this $sign and then type your text. Say for example MATLAB, enter. So you see there is no execution of any command here because MATLAB would consider this one as a text, not a command. So the other important point is that the order of precedence is important in MATLAB. Say for example, if you have parentheses, MATLAB would first execute those parentheses, then the second precedence belongs to exponentiation, then multiplication and division, and finally addition and subtraction. And it will do these commands in order from left to right. Say for example, if I have 7 plus A divided by 2, enter, it will return 11 for me, but if I put the addition inside parentheses. 7 plus 8 divided by 2, enter. The result is different because for the last command, the addition is executed first and then the division is done. So parentheses, exponentiation, multiplication, and division, and finally addition and subtraction is the order of precedence in MATLAB. As another example, if I type 4 plus 5 divided by 3 plus 2, enter. Here 5 divided by 3 is executed first and then the addition operations are done. Now if I put the addition 4 plus 5 inside parentheses, slash, open the other parentheses, 3 plus 2, enter, you see the result is different here. For exponentiation example, if I type 5 to the power of 3 divided by 2, 5 to the power of 3 divided by 2, enter, it returns 62.5. Now 5 to the power of, open parentheses, 3 divided by 2, enter, the result is different here because this time 3 divided by 2 is executed first, but here 5 to the power of 3 is executed first. Again, I would type CLC, enter. As another example, I would have 27 to the power of, open parentheses, 1 over 3, close parentheses, enter. Now what if I type 27 to the power of 1 over 3, enter. Again, you see the result is different because here 27 is first taken to the power of 1 and then divided by 3, but here 1 over 3 is executed first. Now again, I will type CLC, enter, and here I'm going to review some of the formats for decimal places that we have in MATLAB. So if I assign this value to A, 290 divided by 7, enter. So this is the value of A. Now if I type format short, format space short, enter. And what if I type A here, A, enter? You see I have 4 decimal places for my A, for the value of A here. Now if I type format long, enter, A, enter, here I have 15 decimal places for my variable. Now what if I type format short E, enter, A, enter. Here you see that we have the scientific format for my variable, 4.1429 e to the power of 1. Now if I type format long E, enter. So I didn't put G here, I would type format long E, enter, A, enter, and here I have the scientific format for my number with 15 decimal places. Now if I type format bank, enter, and here A, enter, you see I have these 2 decimals which can represent cents, so $41.43. Now again, I would type CLC to clear the command window and enter. MATLAB has a large library of built-in functions. Now here, if I type %, functions, enter, you see, as I used the % here, no errors, error message, no execution of command appears here. Now what if I don't type this %? If I type functions, enter, MATLAB would pop up this error that this function is not defined yet. Now, as another example, if I type 5 plus 3, enter, it would return the result of this addition for me. But if I type the %, 5 plus 3, enter, MATLAB would consider whatever I type after the % as a text, not a command. So here's the use of the % in MATLAB. Type CLC to clear this command window. Now as an example of the built-in functions, sqrt of 25 would return the square root of 25 for me. Now another frequently used function in MATLAB, nthroot, and here you can see the syntax for this function appears here. After nthroot, you need to open a parenthesis, type the number, and type the n, the degree that you're looking for as the root. So here, if I type 27,3, close the parenthesis, enter, would return 3. It means that 3 to the power of 3 would return 27. Nthroot of 64, 3, enter, would return 4. It means that 4 to the power of 3 would return 64. As another example, nthroot of 125, 3, close the parenthesis, enter, would return 5, which means that 5 to the power of 3 is equal to 125. Now I would type CLC to clear this command window. We have exponential function, exponential of 1, which would return exponential of 1, would return the base of natural log for me, 2.7183. As another example, we have absolute value, ABS, open the parenthesis, -24, enter, would return the absolute value of the argument inside the parenthesis. Now I would have log of x. So again, here you can see we have the syntax for the function. Now if I type e, exponential of 1 here, and close the parenthesis, enter, would return 1. So log of x is equal to natural log of x. So I would type it here as a text. Log of x is equal to natural log of x in MATLAB. Enter. So this is just a text here. We also have log 10 of x. If you type log 10, open the parentheses, and again this syntax appears here. So log of log 10 of 1000, for example, close the parentheses, enter, would return 3 for me. It means that 10 to the power of 3 is equal to 1000. Another function is factorial. Factorial, open the parentheses, again this syntax appear here, factorial of 5, enter, which return 120 for me. CLC and clear the command window. We also have trigonometric functions in MATLAB. Now here if I type sine of pi over 6, close the parentheses, enter. So this is how we type pi in MATLAB. And when you type sine, open the parentheses, MATLAB would assume that your angle is in radians. But if I type sine d, open the parentheses, then you need to enter the angle in degrees. So 30, close the parentheses and enter. The same result returns here. Now cosine, open the parentheses, pi over 3.5, cosine d, open the parentheses and 6d, close the parentheses, enter, again 0.5. So whenever you type cosine d, you need to enter the angle in degrees, but cosine without d, the angle is in radians. We have also tangent of pi over 3, or tangent d 6d. Enter. The same result, 1.5, 1.7, 1.7. We have cotangent of pi over 3 and cotangent d 6d. Close the parentheses, enter, 0.57, 0.57. So always notice that you need to type the angle in degrees when you have cotangent d, and when you don't have the d letter here, you need to type the angle in radians. Now we also have arc cosine and arc sine functions. A sine of 0.5, enter, would give me this result, which if I multiply this value, if I type answer, multiply it by 180 over pi, enter, it would give me 30 degrees. So here again, I didn't put a d here, that's why I get the result in radians. Now if I type a sine d 0.5, enter, here I get 30 degrees. And here I converted my units from radians to degree, but here I don't need to convert the units because I already have the angle in degrees. Now as an example, if I type CLC here to clear the command window, as an example I have this right triangle. I have the sides 3, 4 and 5, and I want to find these two angles A and B. In a right triangle, the sine of any of these acute angles is the side opposite the angle divided by the hypotenuse. So A would be equal to arc sine 3 over 5, and B would be equal to arc sine 4 divided by 5. Because here the sine of B would be 4 divided by 5, and so B would be arc sine 4 divided by 5. Now in the command window, if I type a is equal to a sine 3/5, enter, it would return the value of a in radians for me because there is no d letter here in front of a sine. Now, if I want to assign a new value in degrees to a, I can type a is equal to a multiplied by 180 divided by pi. Enter. So this is the value of a in degrees. This is the value of a in radians. So this is how we assign a new value to our variables. The previous value was this, and here I am defining a new value for my a. And from now on, MATLAB would consider this value for my a, not this one. Now again, if I type a equals a, then enter, again it would return the last value for a, not the previous one. So for the angle B, I would have a sine 4 divided by 5, enter, and now I'm gonna assign a new value to B to convert radians to degrees. B is equal to B multiplied by 180 divided by pi. Enter. So this is the angle B in degrees. Now I can make sure that my angles are correct. I can type A plus B plus 90. So as you know, in a triangle, the summation of the angles, the inner angles would be equal to 180. So here A plus B plus 90 should be equal to 180. Again, I would type CLC, enter. Now again, if I, for example, assign a value to my variable x is equal to 12, enter. Now, if I define a new expression for my variable x plus 11, enter, x is no longer considered as 12 because I have defined a new expression for my variable. Now you can also define, assign different values to your variables. The semicolon to suppress the execution of this command, and b equals sign 11 semicolon. Here, if I define a new variable as this expression a plus b divided by a minus b. Now, as I want to operate a plus b first and then this division, I need to put this inside parentheses. The same for this term here. Then enter. So now I have defined two variables. I have assigned some values to two variables, and here I have assigned an expression to another variable, and the result is returned here. Again, I would type CLC. When you want to define a new variable in MATLAB, please notice that you need to start with a letter. The name that you choose can contain digits and underscore, but not other punctuation characters. And also note that MATLAB is case sensitive. Now, if I type A, capital A, and small a, and then assign this value to this variable, enter. Now, if I type small a, capital A, enter, AA is not defined in MATLAB. and it is asking, did you mean capital A, small a? And now if I enter, it will return 10 for me. And also A is also capital, both of them capital, is also different from this variable. You see again, this one is not defined in MATLAB. And you can always clear your previously defined variables in MATLAB by typing clear. Say, for example, if I type A, capital A, enter, it will return 10 for me. Now if I type clear, then enter, and here A, enter. So this one is no longer defined. Now if I clear the command window, CLC, as another example, suppose that A is equal to 1. Now if I type clear, enter, A, enter, but here, as I typed clear command, A is no longer defined. There are some built-in keywords and variables in MATLAB. So, for example, clear. So, like break, enter. You see, it would pop up this error that it needs to be inside a loop, and there's no loop here. Now, if you type is keyword, enter, MATLAB would list a number of predefined variables that you cannot use as your own variables. So always make sure that when you define a variable, you exclude these names for your variables. Again, I would type CLC. You can define vectors and arrays in MATLAB. Say, for example, if I define this variable, open the square bracket, 2000 space 2001 space 2003 space 2004 square bracket, enter, it would return a row vector. Now again, if I define year as open the square bracket, 2000 semicolon 2001 semicolon 2003 semicolon 2004, close the square bracket, enter. This time I would get a column vector. So this is how we get row vectors and column vectors in MATLAB. Now if I define this variable as -2 column 2 column 14, enter, so it would give me an array for x starting with -2, the increment is 2, and the last element is 14. So this is how you define a range for your variable. Now if I eliminate this increment here, this number 2, so x is equal to -2 column 14, enter, the default would be 1 for the increment if I eliminate this increment from my array. Now we also have this function linearly space. So if I type lin space open the parentheses 2, 4, 11, and here you can see the syntax for this function, close the parentheses and enter. Here you can see that the first element is 2, the last element, final element is 4, and 11 element between 2 and 4 is returned here as an array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The entire number of elements is 11. So now we also can create matrices in MATLAB. Say, for example, I define x as, open the square bracket and type 1 space 2 space 3 semicolon, 4 space 5 space 6 semicolon, 7 space 8 space 9, close the square bracket, enter. Now I have a 3 by 3 matrix. And now I can have identical matrices. If I type E, Y, E, I of 3, enter, it would return an identical matrix for me, a 3 by 3 identical matrix, which had 1s on the diagonal and 0s on other elements, for other elements. I have 0s, open parenthesis 3, enter, it would return a 3 by 3 0 matrix for me. Now if I type 0s, 3, 4, enter, it would return a 0 matrix, and the dimension for the matrix is 3 by 4. Now what if I type 1s, 3, enter, it would return a matrix in which all the elements are 1, and 1, open the parenthesis 3, 4, enter, a 3 by 4, 1 matrix is returned here. Now again, CLC to clear the command window. You can find the inverse and the determinant of a matrix in MATLAB. For example, if I have A as 2 space 1 space 4 semicolon, 4 space 1 space 8 semicolon, 2 space -1 space 3, close the square bracket, enter. So I have this 3 by 3 matrix. And notice that for a matrix, in order to have the inverse, the matrix has to be a square, and the determinant of the matrix should be a non-zero value. Now, I first find the determinant of A, enter, which is equal to 2. So the determinant is non-zero. Now I can have this new variable, and I would assign inverse of A, enter. So this is a 3 by 3 matrix, which is the inverse of matrix A. And you can check this result by multiplying A and B, A asterisk B, enter, and an identical matrix would be returned here, which shows that A and B are in fact inverse matrices. So I would type CLC to clear the window, and now I have this example here. Use matrix operations to solve the following system of linear equations. We have 3 equations, 3 unknowns, and we can write this system of equation as matrices. We have this matrix of coefficients, this vector of unknowns, and this vector of the result of these equations. Now I can rewrite this system of equation on my command window. If I define A as this 3 by 3 matrix, so I would have 4 space -2 space 6 semicolon, 2 space 8 space 2 semicolon, 6 space 10 space 3, and close the square bracket, enter. So this is my matrix of coefficients. For B I have, open the square bracket, 8 semicolon 4 semicolon 0 and close the square bracket, enter. So I have this column vector here. Now I have, if I use the percent sign, then I can type A times X is equal to B. This is what we have here in this example. So this is my A matrix. This is the vector of unknowns, X. And this is the vector of the result of these equations, B. So here, if I multiply both sides of this equation by inverse of A, so the percent sign is to make the make this text as a text, not a command. So inverse of A multiplied by A times X is equal to inverse of A multiplied by B. So inverse of A multiplied by A would return the identical matrix. So this side of the equation, I would have X equal to inverse of A times B. Enter. So this is how we get our unknowns here. So X is equal to, I no longer use this percent sign because I want to execute this command here. So inverse of A multiplied by B, enter. So this is the value for X, this is the value for Y, and this is the value that we get for Z unknown. So these are the three unknowns that are obtained here. Now again I would type CLC to clear the window. So far you might have recognized that on the command window you are not able to edit your commands. Once a command is executed, it cannot be edited. So in order to save and edit your codes and commands, you can use this tool on the upper left corner of the ribbon. Click on New Script, and here you can save your script on desktop. And I would type example 2, save. Now here I can, if I click on this command window and use these arrow keys, the upward arrow, I can access the recently typed commands. Now, for example, here I want to use this command, copy this here, now again the upward arrow key, so I have this vector B here, copy this and paste it here. I have this text here that I can add for more clarification here. Paste it here, and now as a last command I would type X is equal to inverse of A asterisk B. And now if I click on this run option on the ribbon, it will run the entire code for me. So I have this A matrix B, and my unknowns. So, and this one was here at the beginning. Now, what if I use some semicolons here? So here I would clear the command window. Now if I run this one, it will type example 2 and would run the script here and would return the x, y, and z values for me. Again, I would type CLC to clear this command window, and as this one is saved, you can make sure that it is saved and then close this script and continue here. Now, how to plot a set of data in MATLAB. So here I would define a range for my x values. X is equal to linearly space, open the parentheses, 0, 50, 50, close the parentheses, semicolon, enter. So the first element is my first element in this x array, 50 is the final element, and this last number shows the number of elements between 0 and 50, including the first element and the final element. Now I would define y as sine of x, semicolon, enter. Now plot x and y, enter. So the plot is created here. Now you see we have sharp edges. If I define a finer mesh for my x values, so use the arrow keys and select this one, and this time I'm gonna type 500 as the number of elements between my first and final element. Now again use the arrow key, y is sine of x. Now enter, use the arrow key and select plot x and y, enter. Now if you open the plot, you can see we have a much finer and much smoother plot for this set of data. Now I can add labels to x-axis and y-axis. Here in the command window, if I type x label, open the parentheses, use the quotation mark, and then type time, square bracket, second, close the square bracket, and you can enter a space here, the quotation mark, close the parentheses, and enter. So we have title for our x-axis here. Now y label, open the parentheses, something like energy, for example, energy in joules. Now enter. This time we have label for our y-axis. Now if you use the title command, title, energy versus time, close the parentheses and enter. Now this time if you open the plot, you can see the title has been entered for the plot. So I would close this, clear the command window. Now what if rather than multiplying two scalar values, I need to multiply two arrays of values. Now, for example, if I define x as linearly spaced 0, 1, 11. Enter. You see we have 0 and 1 and these 11 numbers between 0 and 1, including 0 and 1. Now I define y as sine of cosine of pi. So here's the example that I have it here. So we have this array for this independent variable, and we want to plot y as cosine pi x times sine pi times x. So in order to get this command, we need to type this and type like this. And here we need this dot multiplication command because we are multiplying two arrays. And for this one, the dot command is not needed because we're multiplying a scalar value with this array. But here, between these two terms, we're multiplying two arrays. And this dot command will make this element-wise operation. So I would write this equation here, pi asterisk x, close the parenthesis, dot asterisk, sine, open the parenthesis, pi asterisk x, close the parenthesis, then enter. So we have corresponding values for this independent variable here. Now you can plot x and y. And again, you see we have these sharp edges if I define. So again here, I would add a 0 here, semicolon, enter. Again the arrow key and use enter this y function here, semicolon, enter, use the arrow key, plot x and y, enter. Now if you look at the plot, we would have a smoother plot now, as we defined a larger number of elements between the first element and last element for X array. So this is how we plot a set of data in MATLAB. Here notice that we have all the variables that we defined listed here in workspace. And you can recall whatever variables that you have defined in your programming.